Back to a new video. Today we're going to be talking about topic 3 and I think 13 of the IB chemistry syllabus, and in this we're going to be talking about the group 1 metals or the chemistry of alkali metals, and presented by yours truly. Let's start off with what are alkali metals. As we all know, or we may know, alkali metals are the group 1, so they are the elements that are found in the first column of the periodic table. They are called alkali metals because they form alkaline solutions when they react with water. It is a basic or alkaline solution. Similarly, if nonmetals react with it, they form acidic solutions. So these are alkali, given the name because of their basic solution. They are also really highly reactive because they have a single valence electron. Group 1 means one valence electron, which makes them having the tendency of metals to lose one electron, making them extremely reactive or eager to react. Let's talk about the physical properties. Number 1, they're soft and dense. They can be cut with a knife, which is one of the classified and special properties that these metals have. Their density increases as you move down the group, but still they are the least dense amongst the metals. We will also see that they are lustrous but tarnishing. They have a shiny metallic luster when freshly cut. So if you freshly cut it, it will be shiny, but really quickly, because they're so reactive, they will dull down or tarnish because of reaction with the air and oxygen. They are excellent conductors. They're thermal and electrical conductors because of the delocalized electrons that are present in their metallic structure, which we will discuss in a later video. These electrons move throughout the structure, carrying the electric current or the heat, making them good conductors. Next, we would also talk about the low melting points. The melting point decreases down the group. They become softer, so the melting point decreases. This is also because of the topic of atomic radii. When we go down a group, there is an increase in the number of shells as the period increases. This means that there's weak attraction between the nucleus and all of the surrounding atoms and the farthest electron. Sorry, I meant to say electrons. As this distance becomes bigger and bigger, there is a weak bonding between them, leading to them to have lower melting points, because lower temperatures can easily break it apart because you need less energy to break a structure which has lower bonding. Let's say if I'm holding someone's hand very lightly and someone comes and immediately cuts it through, it will easily fall. But if I am holding their hand really, really tightly, it will take more and more energy. Similarly to this form of melting points of alkali metals. Now let's move on to the chemical properties, which we need to know is reactivity. First of all, because of their single valence electrons, they are highly reactive and they can readily lose this electron to form a positive ion of +1 charge to achieve this stable noble gas electron configuration. They can react with water and oxygen. With water, they form oxides, peroxides, superoxides. But when they react with water, they form hydrogen gas and the specific alkaline hydroxide, and they also are as an exothermic reaction, so it produces a lot of heat. Also, the reactivity increases down the group. As the atomic size increases, as I said, the outermost electron is further, it's easier to pluck off, hence it reacts more and it increases its reactivity. Let's talk about the reaction with water. The alkali metals react with water and it visibly increases down the group as reactivity increases down the group. It increases from strong to vigorous and extremely vigorous reactions, which are keywords that we should need to know. When it reacts with lithium, it floats. Lithium floats after reacting and it reacts slowly because it's the least reactive metal. Bubbles of hydrogen gas are released and it's the least vigorous reaction. But when it reacts with sodium, it's more vigorous. And the heat that is released is enough to melt the sodium so that we can, and that in the reaction, we can see a metal floating on the surface because of the melted sodium. It produces more heat than lithium, and it is a little more reactive. Well, the last one I'd like to talk about is potassium. It reacts violently and extremely vigorously. It melts into a ball, and the heat is so much that it can ignite the hydrogen gas and produce a colored flame. So it's highly exothermic and produces a flame, as written here. A key thing about alkali metals is they burn with a specific color. Here in this chart, it's not really visible, but you can see that lithium produces a red flame. This is important to know. Sodium produces a yellowish flame. Potassium produces a lilac flame. Rubidium, which is another metal, produces a ruby colored flame, and cesium produces a purple flame. So these are also important things which you should know, which can be asked in the examination. Let's talk about the reactions with water. I'm going to first, for your ease, give you a general equation to help you understand what I'm doing. The metal here, M here, is the metal, the alkali metal we're using, and that's always a solid. Water is a liquid, and the hydroxide that is formed. As in my old video that I've uploaded, I've explained this too, but OH is the hydroxide formula, and that is aqueous, and the H2 is a gas. So when we write these all, we need to balance it. If there was no 2's here, there would be 1 plus 2, 3 hydrogens. Hence, we need to balance, so we put a 2 here, which becomes 4 hydrogens. So you have to put a 2 here, which there's 4 hydrogens, but there's 2 oxygens. Here we check again, yes, 2 oxygens, but here there's 2M, and if we had no 2 here, they would just be M. So you have to add a 2, and this is how we get the balanced equation. An example of this is with lithium. It forms lithium hydroxide, so it's basically just the name plus hydroxide, and it forms hydrogen gas, which is seen 2 lithium plus 2 water gives 2 lithium hydroxide and gas. Similarly, in rubidium, 2 rubidium plus 2 water gives 2 lithium rubidium hydroxide and hydrogen gas. This is a great thing for us to know, and a challenge for you after looking at these. Try not to look at this and write a balanced equation for cesium, CS reacting with water. And just to sort of fun fact, it's the most stable alkali metal. I will be talking about the structure of lithium hydroxide and forming with charges and all in another video. So please like, share, and subscribe to this video so it supports the most. Okay, next we're going to be moving on to reaction with halides. These are group 17 metals called halogens, and these alkali metals react with these halogens or the group 17 metals to form ionic salt, or also called as alkali metal halides. This is some key vocabulary which you will understand soon. So the general reaction is you put the alkali metal and the halogen that are reacting, and it simply just gives you the alkali metal halide salt. An example that I'd be taking is sodium and chlorine. Here you put 2 sodium and chlorine you put here, which forms NaCl, which is your alkali metal halide. I'm sorry, my pronunciation is bad. This is also known as table salt or sodium chloride. I would like to talk about the reactivity trend. The reaction in the halogens, which is something we should know, becomes increasingly vigorous down the group, up the group, sorry. I'm confusing between alkali metals. When we go down the group 17 halogens become more reactive when we go up, while the group 1 metals become more reactive when we go down. So this is a reactivity trend, which is something you may know of or not. I'll discuss this in another video when we talk about the reactivity series. Now, a challenge for you is to use the similar things that we've learned in this slide to write a balanced equation for lithium reacting with bromide to form its respective alkali metal halide salt. Now, I will be ending each question with some IB example questions, and so in this video, let's test your understanding of physical properties of alkali metals, specifically its melting point and density, as well as their reactivity with water. So, pause the video and take your time to understand and read the question and get an answer. I'll be discussing it in very shortly. Alright, so if you're back, let's discuss this. Which property increases down group 1, the alkali metals? Is it the atomic radius, the electronegativity, the first ionization energy, or the melting point? Since right now we have not really discussed 2 of these, let's consider the other ones. Which increases down the group? First of all, we know that the atomic radius, does that increase down the group? Yes, it does. Electronegativity, first ionization energy, or the melting point. These are 3 things which does not increase down the group. Rather, melting point decreases down the group for alkali 1 metals. So the answer for this is A, atomic radius. Another question we have, pause and take your time, and this one focuses on the reactions with the alkali metals and water. Remember to use what we learned. All right, we are back. Which statements about reactivity are correct? Potassium reacts more vigorously than sodium with chlorine. I said that the reactivity of alkali metals increases down the group. Is potassium lower than sodium on the group? Yes. We'll come back to this one. Lithium reacts more vigorously than potassium with water? No. As we know, down the group it increases, lithium is higher, so B is wrong. Fluorine reacts more vigorously than bromine with a potassium iodide solution. I had briefly mentioned in this video that the group 17, or the halogens, the reactivity increases up the group. The first element which we see is fluorine, which is the most reactive, and anything under that is less reactive. So number 3 is correct. In this, we know that number 3 and number 1 are correct. Hence, the correct answer is B, 37B. My trick for these type of questions is also to narrow it down. If you know that one is certainly wrong, like if we're unsure, let's say, as I said, would move skipping the first one. If we're unsure, let's just say that we for sure know that 2 is wrong. So when 2 is wrong, we eliminate option A, C, and D. So ultimately, we'll get option B. This is just a time-saving technique, but it's also something which is very useful. And that is it for this video. I hope you guys understood more about alkali metals. Leave any questions you have in the comments below. I will be sure to answer them, or you can email me with the info in my bio. Thank you and good luck studying.